Hi, my name is Gerilyn. I'm using programming as part of my work with small businesses and entrepreneurs who need reliable web services. Creating functions. In the last chapter, we learned how to create variables and use them in expressions. In this chapter, we are going to build on that knowledge to create functions. Functions are groups of commands we give to the computer. We've already used functions, for example, the print function and the drawLine function. Now, we are going to make our own functions. Functions help us by making our code easier to read. By writing our own functions, we can have functions to draw tree and draw horse, which is a lot easier to read than long blocks of code that just draw lines and rectangles. Abstracting our code. By using variables, we can abstract our code and tell a function where to draw a tree, how big to draw it, and what color to draw it. This is a lot more flexible than one set of code that can only draw a tree in one exact place and one exact size. Reusing our code. By calling a function, I can reuse code over and over. If it takes 10 lines of code to draw a horse, I can put that in a function. Then, if I want to draw 3 horses, I don't need 30 lines of code to do it. Dividing a complex problem into simpler ones. The key to programming, and a lot of things in life, is to learn how to take a large, overwhelmingly complex problem and divide it into small problems. For example, we have functions that can display dots on the screen. Then there are functions that can draw a line using those dots. Then functions can draw triangles using those lines. Then functions can draw trees using those triangles. Then, finally, a forest function that uses the trees function. Drawing a complex forest is broken down into simple functions that build off each other. Making code easier to maintain. If there is a problem in your program, it is easier to find when your program is divided into parts. If your car isn't moving correctly, and there's a move car function, that's easy to find. Plus, if all cars move using that function, I can fix a problem for every car in my game in one spot. Creating simple functions. Defining a function in Python is easy. Here's an example. To write a function, start with the keyword def, which is short for define. Next, give the function a name. Function names follow the same rules that variable names follow. They must start with a lowercase letter, or in special cases, an underscore. After the first letter, only use letters, numbers, and underscores. Spaces are not allowed. Use underscores instead. While uppercase letters can be used, function names are normally all lowercase. After that, we have a set of parentheses. Inside the parentheses will go parameters. We'll explain those in a bit. Next, a colon. All the code that goes in the function will be on the following lines. That code must be indented 4 spaces. The first line that is not indented signifies the function is done. Usually, we start a function with a multi-line comment that explains what the function does. Note: function definitions go below the import statements and above the rest of the program. While you can put them somewhere else, you shouldn't. Defining a function doesn't cause the computer to do anything. It is like giving a recipe to the computer. Give someone a recipe for banana bread, and they know how to make it. They haven't actually made it yet. They just know how. You have to tell them to make banana bread. That is, After we define the function, we must call the function before the code in it runs. To call a function, type the function name and follow it by parentheses. Do not use def. That's only used when we define what the function does, not when we tell the computer to run it. Below is a program that defines print hello, then calls it twice. You can define and use multiple functions, but all function definitions should go before the main code. In this example, see how we've defined two functions and then we can call them in our main code. Actually, almost all code should go in a function. It is a good practice to put the main starting point of your program in a function called main and call it. In this next example, we do just that. See how we took the two function calls and put them in the main function. Also note that we call main at the end. Without that, our program won't do anything at all. Remember how our drawing code always starts with import arcade? That just imports a lot of functions that are defined in the arcade library so we can use those functions ourselves. It doesn't run anything, just imports functions. Eventually, we'll learn to write our own modules we import. Right now, we couldn't do that with our code because attempting to import the code would actually run it. What we want is simply to make the functions available for us to use. With that in mind, a better habit to get into is to check if we are trying to import the file before calling the main function. The statement in this next example looks a little weird. In fact, it's weird enough I just look it up and copy-paste it anytime I want to use it. Don't worry about understanding how it works yet. Just realize it is a good practice and why. If this is too confusing, just call the main method instead. Eventually, we'll learn about imports and if statements. Then, it'll make more sense. Take in data with parameters. Functions are even more powerful if we can feed data into them to process. Here's a simple example that will take in a number and print it. Notice how I've created a new variable, my number, in between the parentheses. This is called a function parameter. It is just a variable that is given a value equal to what is passed in what we called. In the example below, it is given first a 55, then 25, and finally a 5. You can pass in multiple numbers. Just separate them with a comma. In this case, A will be 11 and B will be 7. Occasionally, new programmers want to set the parameter values inside the function. This is wrong. If you do this, the function would only work for those values. The power is in specifying the numbers outside the function. We don't want the function to be limited to only certain data values. This example works, but it is wrong. Because if we ever changed line 8 to pass in different values, the program would ignore those values because on lines 3 and 4, they are always overwritten with 11 and 7. Returning and capturing values. Functions can not only take in values, functions can return values. Returning values. For example, here is a function that returns two numbers added together. See how it uses a return statement on line 4 to return the result out of the function. Note: return is not a function and does not use parentheses. Don't do return result. This only gets us halfway there, because if we call the function now, not much happens. Take a look at this example. The numbers get added. They get returned to us. But we do nothing with the result. So if you run this program, nothing prints to the screen, and we can't tell that anything happened. Capturing return values. We need to capture the result. We do that by setting a variable equal to the value the function returned. In this next code example, we captured the result by putting a variable to the left of the function call and using the equal assignment operator. Later, the code prints the value, but that's not capturing. That's just using the result we captured and printing it. Now, the result isn't lost. It is stored in the myResult variable, which we can print or use some other way. We will do this a lot, so pause for a second and let it sit in your mind. I'll wait. Great! Now imagine you have an instructor or coworker watching over your shoulder. You have a function. It returns a value. The person over your shoulder says, "Okay, now you just have to capture the value." The pressure is on. Don't panic. Remember, to capture the value returned from a function, put a variable to the left of it and use an equal operator. Volume cylinder example. Let's use what we learned for something more practical. Here's a function that returns the volume of a cylinder. Notice how we take two parameters and return the result of the calculation. Because of the return, this function could be used later on as part of an equation to calculate the volume of a six-pack like this. See how the value returned from volume cylinder goes into the equation and is multiplied by 6. We would not be able to chain together calculations like that if all we could do was print instead of return. There is a big difference between a function that prints a value and a function that returns a value. Look at the code below. Pause for a bit and make sure you can follow how it works. Read the comments. This is a common source of confusion for new programmers, so spend a bit of time studying it. This next code example has a very common issue new programmers face. It's not unusual to get stuck looking at code like this example below. Your task. How would you print the result of the function? See if you can figure it out without looking ahead. What's the answer? How do we print the result of calculate average? In the code above, the program can't print the result because the result variable only exists inside the function. Instead, use a new variable outside the function and the equal operator to capture the result. Documenting functions. Functions in Python typically have a comment as the first statement of the function. This comment is delimited using 3 double quotes and is called a docstring. In this case, the docstring is on line 2. The great thing about using docstrings in functions is that the comment can be pulled out and put into a website. That can be part of a larger website that documents your code. For example, here is the documentation for drawing a circle, generated automatically from the function comment. In fact, everything on that page is automatically generated. Most languages have similar tools that can help make documenting a breeze. This can save a lot of time as you start working with larger programs. Variable scope. The use of functions introduces the concept of scope. Scope is where in the code a variable is alive and can be accessed. For example, look at the code below. The last line will generate an error because x only exists inside of the f function. Ever heard the phrase, "What happens in Vegas stays in Vegas"? Well, variables created in a function stay in the function. The variable is created when f is called and the memory it uses is freed as soon as f finishes. Here's where it gets complicated. A more confusing rule is how to access variables created outside of the f function. In the following code, x is created before the f function and thus can be read from inside the f function. Variables created ahead of a function may be read inside of the function only if the function does not change the value. This code, very similar to the code above, will fail. The computer will claim it doesn't know what x is. Pass by copy. When you call a function and set a value to a function parameter, that value is a copy of the original. For example, take a look at this code. The value of y does not change, even though the f function increases the value passed to it. Each of the variables listed as a parameter in a function is a brand new variable. The value of that variable is copied from where it is called. This is reasonably straightforward in the prior example. Where it gets confusing is if both the code that calls the function and the function itself have variables named the same. The code below is identical to the prior listing, but rather than use y, it uses x. The output is the same as the program that uses y. Even though both the function and the surrounding code uses x for a variable name, there are actually two different variables. There is the variable x that exists inside of the function, and a different variable x that exists outside the function.